Hi students, today's session we are going to see the problems based on 0, 2L. So for this, the general Fourier series for this interval 0, 2L is given by f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos n pi x by L plus summation n is equal to 1 to infinity b n sin n pi x by L. So here the previous model, that is the problems on 0, 2 pi. So we have a only cos nx only have, but here the 0, 2L, it is comes under the length. So therefore cos n pi x by L plus summation n is equal to 1 to n bn sin n pi x by L. We know the phi a naught is equal to 1 by L. So previous model we put 1 by pi. So in here we have to apply 1 by L, 0 to 2L f of x dx. Then an is equal to 1 by L integral 0 to 2L f of x cos n pi x by L dx. Then bn is equal to 1 by L integral 0 to 2L f of x sin n pi x by L dx. So this is the formulas we are going to use for the problem. Next we are going to see the problem. Find the Fourier series of period 2L for the function f of x is equal to x into 2L minus x in the interval 0, 2L, and hence reduce the sum of the f of x is equal to 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc. Solution. So first we are going to see write the Fourier series, general Fourier series for the interval 0, 2L. F of x is equal to this one. Then next we are going to calculate the a naught value. So a naught is equal to 1 by L integral 0 to 2L f of x is dx. So what is our f of x is given? X into 2L minus x. So here substitute x into 2L minus x dx. Then 1 by L. So here multiply the x inside, you will get the 2Lx minus x square. So integration of 2Lx is, we can write 2Lx square by 2. So the 2 will cancel. So only will get the Lx square minus multiplication of this one, you get the x square. Integration of x square is x cube by 3. Now apply the limit 0 to 2L. So if you apply the limit 0 to 2L, applying the upper limit, here you will get the 2L, 4L square, 4L cube will come. Then minus here also 4L cube by 3. So here take the LCM as 3. So we can get 12L cube minus 4x cube by 3. So we'll get the remaining term 4 by 3 L square. Then here cancel L cube, L cancel, get the 4 by 3 L square. Next we are going to calculate the an value. So an is equal to 1 by L integral 0 to 2L x into 2L minus, that is f of x is here x into 2L minus x into cos n pi x by L dx. So here also we are going to apply the Bernoulli formula. So consider u is equal to 2Lx minus x square. Then dv is equal to cos n pi x by L dx. So first differentiate this one. So what is the differentiation of this one? You will get the 2L minus 2x will come. Then again differentiate, you will get the 2L minus 2. That is differentiation of minus. Here the differentiation of 2L is 0. Only differentiation of minus 2x only will get the minus 2. Then integration of causes, you will get the sin n pi x by L divide by what is the coefficient of x we have? N pi by L. So that we have to write in the denominator n pi by L. Then again integrate, sin integration of sin is, you will get the minus cos n pi x by L. Already one n pi by L having, again one n pi by L. So therefore we can return n square pi square by L square. Then again the differentiation of causes, will get the sin n pi x by L divide by, get the n cube pi cube by L cube. So now apply the upper limit. So if you apply the upper limit, so here you will get the, so instead of x only had to apply the 2L. So that L cancel, you get the sin 2n pi. So I already explained that sin 2n pi value is equal to 0. So only cos 2n pi value is 1. So here the first term and the last term become a 0. Then only apply for the center middle term, that is a 2L minus 4L. So you'll get the minus 2L will come. Then here cos 2n pi value is 1. So minus 1 by n square pi square by L square will come. Then apply the lower limit. So while applying the lower limit, this become a 0. So only you get the 2L. 2L into 1 by n square pi square by L square. So for both the term we have a 2L is common. So we can take out the 2L outside. So one day we'll get the minus 1 minus 2. So minus 1 minus 2. Sorry, here the minus 1. Here that is, we know the cos 2n pi value is 1. So apply, after finding the value, we'll get the minus 4 L square by n square pi square. The next we are going to find the bn value. So bn is equal to, the formula is 1 by L integral 0 to 2L f of x sin n pi x by L. What is here? F of x is given x into 2l minus x. So here also we are going to apply the Bernoulli formula. So consider u is equal to x into 2l minus x. Then dv is equal to sin n pi x by l into dx. So use there is a u is equal to this one, u dash this one, u double dash is equal to this one. Then integration of sin is minus cos n pi x by l by n pi by l. Again integration of the sin is cos is, we'll get the minus, already minus is having, so minus sin n pi x by l by n square pi square by l square. So if you apply the upper limit, so we'll get the this value is equal to fully 0. We find out a naught, a n and b n. So now we have to apply in the given this general Fourier series. A naught value is equal to 4 by 3 L square. So by 2 if you put, we can cancel the 2, we'll get the 2 by 3 L square. Then a n value, we get the, what is the a n value? 4 L square by n square pi square. Then b n value is equal to 0. So only we'll get the first two terms. The values we got this one. Now we are going to find the deduction part. So for finding the deduction part, so first we have to take the point from the interval 0 to 2l. So this interval is an open interval. So for this open interval, both the endpoints are discontinuous point. That is, this is the open interval. So both the endpoints are discontinuous point. So middle points, in between points, we can say that as a continuity point. So from this, if you substitute if you take x is equal to any value from this interval, then we should get this deduction part. So if you substitute x is equal to 0, so you will get the cos 0. What is the cos 0 value? 1. So cos 0 value is 1. So if you give any value for n, you will get only all the terms become a positive. But here the given deduction part is alternative plus minus sign is given. So therefore, we have to choose some other value. If you choose x is equal to 2l, so if you choose x is equal to 2l, so again you will get the cos 2np value. So cos 2np values already we know that 1. If you give any value for n, you get all the terms become a positive. So these 2 points we can't take. So therefore next go for the middle value. So in the middle value, consider x is equal to l. So x is equal to l is a, what point is that? X is equal to l is a continuity point. So if you take x is equal to l, we get the deduction part. So that point is called the continuity point. So for continuity point, the left side, or that is the sum of the Fourier series, can be written as only f of 2l. So here x is equal to 2l if we substitute this, x is equal to l, that is this point only continuity point. No. So here substitute x is equal to l, you will get l into 2l minus l into l, you will get the l square. Then next one, here also have to put x is equal to l. So l cancel, you will get the cos n pi. So cos n pi value we know that minus 1 whole power n. If we give any value for n, if we give the positive, if we give the odd value, you will get the negative. If you give the even value, you will get the positive. So we get the reduction part 1 by 1 square. That is a next the 1 by 1 square. Then if you give n is equal to even, then here already you have a minus sign is having this side. Then you have to take that is before the summation part, we have the minus is having. So if you multiply the minus, so you get the first term positive, second term negative, then this term positive, then this term negative. Likewise it will go. Then finally we get the reduction 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc. equal to pi square by 12. Next problem. Obtain the Fourier series for f of x of the period 2l and defined by f of x is equal to. So the given f of x is l minus x, which comes under the interval 0 to l. So this is a closed interval. Then 0 in the interval l to 2l. So 0 to l only we have the function is l minus x having, but it is a given period is 2l. But here we have to split the interval 0 to 2l as 0 to l and then l to 2l. So 0 to L only we have the function, L to 2L we doesn't have a function. So in that case you have to put 0. So only take the interval 0 to L. So we know the general Fourier series. Then we are finding the A naught value. A naught is equal to 1 by L integral 0 to L f of x dx integral L to 2L f of x dx. So in this interval we have a f of x is L minus x. In this interval f of x is equal to 0. So therefore the second integral become a 0. So only integrate the first integral. So integration of L into dx is Lx minus integration of x is x square by 2. Then now apply the limit 0 to 2L. So L square minus L square by 2. So here take the LCM as 2. So 2L square minus L square by 2, L square by 2. So already 1 by L is having. So cancel L, L. we get the L by 2. So this is our A0 value. So next we are going to calculate for AN value. So AN is equal to 1 by L, integral 0 to L, L minus x cos n pi x by L dx. Then another integral L to 2L, f of x is equal to 0. So therefore this integral fully become a 0. Then here you have to use the Bernoulli formula. Consider u is equal to L minus x. Then dv is equal to cos n pi x by L into dx. So for differentiation of L minus x's, you will get the minus 1. Then integration of this cos's, you will get the sin n pi x by L divided by n pi by L. Then next again integration of sin, you will get the minus cos n pi x by L by n square pi square by L square. So now using the Bernoulli formula, we return this like this. Then now apply the limit 0 to L. If you apply the upper limit, the first term become a 0. That is L minus L is 0. And already the sign here, if you apply x is equal to L cancel. You will get the sin n pi. What is it? Sin n pi value? 0. So therefore the first term become a 0. Then go for the second term. Here apply x is equal to L. So L cancel. You get the minus cos n pi by n square pi square by L square. So cos n pi value, what is that? Cos n pi value is 1. Cos n pi value is minus 1 the whole power n. Then next to go for the lower limit, the first term become, that is sin 0 value 0. Then this term only will get, so minus into minus plus, then for upper limit minus lower limit, minus will come. So L square by n square pi square. So simplifying this term, we will get the L square by n square pi square into 1 minus of minus 1 whole power n. So in this case, we have to give, if we give the even value, we get the some other value. Then if we give the odd value, get the another value. So likewise, you have to substitute and check, because if you give any of the value, that is, if n is even, here you have to check. Minus 1 the whole square is plus 1. So 1 minus 1, it become a 0. So therefore 0. It is, we can write directly, but if we substitute in the summation, it will be very difficult. So for that one, we are simplifying the term. If we give any n is even value, we get the an value is equal to 0. If we give n is a odd value, we get the 2l by n square pi square. That is a minus 1 the whole cube will get the minus 1. Minus into minus plus. So we'll get the 2l square by n square pi square. So next we are going to calculate the bn value. So bn is equal to 1 by L integral 0 to L, that is f of x sin n pi x by L dx. Then this integral f of x is 0. So this also use a Bernoulli formula. Then apply the limit. The first term only will get. While applying the upper limit, first term becomes 0, because L minus L is 0, no. So here also the cos n pi will come, but 0 into anything 0. For the second term, sin n pi value is 0. So therefore, we leave this one. Next to go for the lower limit, then apply the 0. Here we'll get the L. Then cos 0 value is 1. So minus, already upper limit minus lower limit having, no. So minus L square by n square pi square, then minus 0. So here we can cancel the L, we get the L by n pi. So this is a Bn value. So now we can substitute all the values A0, An, Bn in the general Fourier series. We get the f of x is equal to L by 4 plus 2L by pi square. Summation, this is the An is valid for only n is equal, n is odd. So therefore, in the summation, we have to write n is equal to 1, 3, 5, etc. up to infinity. 1 by n square cos n pi x by L. For this one, no need to apply. For this, this n is summation for n is equal to 1 to infinity. So write as it is. This is a Fourier series for the given function. So over. So next class we will see the next chapter. Thank you.